All right, so you can see right now this is oh, let me see what I'm doing. Okay, so the first part we try to do is some revision on the rules of differentiation. Of course, we don't have time to go through the details, but there are some rules you need to recall from last year's study. Okay, so the first rule is, of course, the power rule. If you differentiate x to power n equals n times x to power n minus 1, I hope everyone could still remember this. And there are other rules as well. I'm not going to go through with you one by one, but if you feel you are not very familiar with those rules, please spend some time and try to familiarize uh, yourselves with those rules because we are going to use them. Okay, so all these rules. All right, and the next thing you need to recall is what we call the Porter rule. Porter rule means when you have two functions, uh, okay, sorry, when you have two expressions, they multiply together, then um, how can we differentiate them? Then you will have separate them into two parts. The first part is u, the second part is v, and you apply the Porter rule. Okay, so if you remember last year in the exam, some of you couldn't apply this in the examination. So remember, when you apply the Porter rule, the rule says you have to differentiate each part of it separately while you're multiplying the other one which is not being differentiated. Okay, so that's the Porter rule. Okay, I give you one example down here. All right, so, oh, sorry. Okay, so please spend some time to look at the things right here. Make sure you understand. I would like you to spend at least 3 minutes on this. So you can pause the videos, spend 3 minutes, try to make sense of this. Okay, I think you'll be fine, but you just need some time to recall the rules. Okay, so don't get stressed out if you feel I'm not familiar with those things. I can't recall anything. Just spend more time. So 3 minutes is just any arbitrary time. You are now watching a video, so you can spend whatever longer the time you want. Okay. Okay. So after you've done that, you are going to do the same thing for the quotient rule. So the quotient rule means you see two things like divided by each other, like u divided by v. Just like if I give you a function like a fx, which equals x squared plus 1. This is the numerator called u, and divided by 2x minus 3, that's v. Okay, so you need to find derivatives. If you still remember the name of derivative, that means the result of differentiation. Okay, sorry. Okay, and all you want to do is try to apply the rule, but this rule is a little bit more complicated, so you might want to do that separately, like you want to do the du dx and then dv dx. Of course, you have to identify what u is and what v is. Okay, and then you use the rule. Okay, the rule is over here, so this is the rule, and you try to do it again. 3 minutes. Try to recall if you can. Okay, so and you spend 3 minutes on it, and so after you've done all this, so that should be around 10 minutes or maybe shorter. Okay, so this is a new thing. This is the new stuff. The new stuff is differentiation of e to the power x. If you still remember, that's e, which is what we call a very natural base for a lot of exponential functions, which is used to describe the natural growth or decay in that sense. All right, so we did that last year in the exponential function. Okay, so go back to see what do we mean by exponential function, and that is just a very special base, and we will see why this is so special in terms of differentiation. Okay, so you see the variable, where's the variable? The variable is in the power. So the variable is x, which is in the power, and the base is e. Remember that e is actually a constant if you want to have more information. So what's the value of e? Still remember that? Okay, you can use your calculator to check. That's 2.718281828. Actually, it goes forever. So it's an irrational number. Okay, but it's not important as long as you know that's the base we're going to use for the following questions. So what's so special about the differentiation of e to the power x? You could see when you have a function fx equals e to the power x. So what does it mean f dash x? So that just means the derivative, okay? So this is just the derivative of what? Of that fx, and that fx is equals e to the power x. So it's so interesting to know that the differentiation of e to the power x is in fact itself e to the power x. Okay, so this is so special because normally we don't have such thing. This is the only thing that's the derivative is itself. Okay, so in terms of rule, you will see if we try to use, still remember that symbol, that's what we call differentiation operator. So if you use that, the operator, you can see that's more impressed. Okay, so you see that's differentiate e to the power x is e to the power x. That normally doesn't happen. For other functions, you see it's not the case. Okay, for example, if you try to do the, how about x squared? So you won't see x squared on the right hand side become 2 times x, right? By using the power rule. So normally the derivative is different to the function being differentiated, but this is the exception. That's the differentiation of e to the power x is e to the power x again. So this is so special. Okay, because this function is so special in terms of differentiation, that's why we need to study it. Okay, so how about like we need to do some simple derivatives? Okay, let's do some practice. How can we differentiate fx equal 2 times e to the power x? Okay, let's try to do it. So let's try to do it in terms of differentiation operator. Okay, so let's do it like f prime x just equals differentiation of 2e to the power x dx. Okay, now focus on that 2. Okay, so this 2 is a constant, so we all understand you can put that 2 to the front. Okay, so right now you just isolate that's d e to the power x against dx. So what's the result? According to that specific rule, differentiation of ex is itself, then you will have 2 times e to the power x. Okay, it's done. Okay, so how about the second one? All right, the second one, you'll see there are 3 terms. All right, 3 terms. Okay, so let's just rewrite them in operator form. So what I'm going to do is separate them. If you know the rule, we can always do it like, you just put that minus sign out of it, plus you put that 4 out of it, and you differentiate the second term. So it's very convenient to use operator, just okay, if they are adding up together, you just need to differentiate one by one, and if you need it, you could put that constant out of the operator. Okay, for the first one, you see that again, dE to the power x over dx, that means itself. How about the second one, dx squared over dx? Okay, so that's what we call the power rule. Okay, so when you use power rule, okay, let me remind you again. So this is the rule. When you differentiate dx to the power n over dx, then it's just n times xn minus 1. That means you just put that 2 to the front and 2 minus 1. Okay, I know some of you must be thinking this is so easy, so but pardon me, I just try to make sure everyone understands. All right, and so this is ax, so that's it. Okay, so the last bit, d constant, is always 0. 3 is a constant, that's it. Okay, for this one, it's a little bit tricky. So e to the power x, but the next one is x to the power e. How can we do that? All right, I will give you 3 minutes. Try to work it out. Okay, now pause the video. It's important. Pause the video. Use your pen and pencil. Try to copy all the things I've written down and try to spend 3 minutes. So that means you might need 5 minutes to go through all the things you've done so far. So I will give you, okay, 5 minutes. Try to do it. Okay. Pause the video, all right? Okay, let's say 5 minutes have gone. Okay, it's of course not the case, but let's pretend you have begun. Okay, so you know, after 5 minutes, how about your answer? What's your answer? Okay, I'm so eager to know, but I can't. So hopefully you've got the correct answer. All right, so I'm going to show this to you. Okay, differentiation of this thing. Okay, oh, all right, so it's wrong actually. Okay, so there are two terms. Let's separate them by using operator. Okay, let's just separate them, and you put that 2 out of the operator. Okay, oh, sorry, my bad. Okay, for the first term, it's just e to the power x, right? E to the power x. Okay, so that means the result would be ex anyway. How about the second one? So is there any rule for x to the power e? Actually, there is. Which rule? This rule, the power rule. Again, why? Because that n actually could be anything. Okay, right now I write n equals to 1, 2, 3, 4, but that's a more general version, and actually could be anything, could be any real number. Okay, that's what we call real number. So it could just be anything, all right? So that means if you apply the power rule, you put that e to the front, and in the power, e minus 1. So that's it. So this is the answer. How many of you have got it right? I'm interested to know. Possibly you can just leave a comment to let me know if you got this right. Okay? Is that all right? So let's move on to next part, which is the chain rule. Okay. The chain rule is very important for us to expand our domain of differentiation. Okay, for example, if you want to differentiate the things like 4x plus 5 with power half, okay, so you try to apply the power rule, but you can't because the base is different. So that's where the chain rule kicks in. Okay, the idea of chain rule is like if you have a function, you need to do dy over dx, but you can't, then you can create a chain. So that chain here is in terms of u. And so that means when you can't differentiate directly of y by using x, then you try to create a train. Okay, so what would be the train in this case? If you can still remember, okay, the train here you need is 4x plus 5. Okay, so once you have 4x plus 5 here, you of course, according to the train rule, you have to get the same thing right here. I hope you still remember. If you can't, if you uh, if you didn't, then possibly you need to go back to have some revisions on that. We spent a lot of time on this last year, right? So that's 4x plus 5 is the train you need for that differentiation. So once you've got that base 4x plus 5, which is the same as 4x plus 5, so you can use the power rule. Can you see this part, which is the power rule, right? This is the power rule. Okay, it's pretty much like you differentiate the u half and du equals half, u half minus 1. It's pretty much like that. Okay, but don't forget you have to differentiate that 4x plus 5 against x. All right, so that means for the second part it becomes 4, and you must multiply that 4 with that half into the front, and so that's 2. So that's it. And of course, some of you would like to rewrite this into that one. That's completely fine, but it's not necessary. Okay, so if you really have trouble to understand this, you can stop here, try to spend like 5 minutes, try to make sense of it. You need to make sense of it. Okay. Try to make sense of it. So try to spend 5 minutes at least. Try to make sure you understand this. If you still can't really get it, you can go back to last year's PowerPoint, which is still in the OneNotes. You can just track the the chain rule, and you can see plenty of it. All right. So after you've spent that time on revision, I assume you've understand the chain rule. Okay, so the problem here, why do we need to go back to chain rule, is because sometimes we're not going to just differentiate e to the power x, but e to the power gx. You see that? Okay, so it's a big difference there. So you see? So the power is another function. Okay, in that case, how can we differentiate? Then you have to apply the chain rule. Okay, so remember the generic rule for differentiation for e to the power x is always e to the power x dx equal that one. But that x is dummy. Do you understand the meaning of dummy? Dummy means you could put anything there. So if I don't have x, how about if I have any other kind? Like if you have theta there, okay, just put anything here, and you differentiate with respect to theta. As long as they are the same, then you will have the same outcome. All right. So the key idea, let me emphasize, okay, you must have e to the power and the variable, okay, you use. They must be the same. They must be compatible before you can apply the rule. Is that okay? So that's why I would like you to try to see whether the following, some of them are correct or not. Okay, so you need to make a decision, all these whether they are correct or not. Okay, how about the first one? d e to the power x over dx is ex. Is that correct? Yes, that's typically the rule. Let's go to a second one. d e to the power u over du equal e to the power u. Are they the same? Let me check. It's U, U, U. Yeah, perfect. It's okay. So how about this one? Let's see. D to the power x. Oh, wait a minute. Is this x? No. Okay, no. No, it's not. Okay, it's not. Okay, so can you get the result? No, they must be the same. Okay, so this is wrong. The problem is that should be, it must be x in this case. It can't be t, right? Okay, let's go on to the next column, which is more difficult. Okay, so I will give you time. Okay, I will give you some 1 minute to go back to see why these are correct and why the last one is wrong. Just think about this in 1 minute's time. And I will try to give you, like another 1 minute. Try to guess it, whether some of them are correct, some of them are not. Try to make your decisions on them. Okay, so 2 minutes time. You can pause the video, spend 2 minutes time. Okay, so you have got 2 minutes. Okay, let's see. How about the first one? What's your opinion? Okay, so that's 2x. So this is an x. Are they the same? Yeah, both are x. Are they the same? And this is 2x. What do you think? All right, so the problem is here. It's not matched. Again, because it's not 2x. So it's not good. Okay. So I would say this is wrong. Okay, how about this one? Let's track. So this is 2x, 2x, 2x. Okay. Do they all match? Yes, they match. Okay, so they're correct. Okay. Oh, I missed 2. Oh, sorry. Sorry, I didn't notate that another 2 down the page. But anyway, we'll finish that. Okay, so let's go to this one. 3t plus 6 t. 3t plus 6. No, the problem is here. Okay, it must be 3t plus 6. Okay, so that means this one's wrong. Okay, so how about the one here? Okay, so it's the t, u, t. Oh, no, not good. Okay, not good. Okay, so not right. And how about this, the last one? 3t plus 6, 3t plus 6, 3 plus 6. Yep. So this one is correct. Okay, so do you understand I hope you've understood that the key is you have to get the numerator and denominator in, okay, using the same, okay, the denominator must have the power which is matched by the variable in the denominator. Okay, otherwise you can't apply the rule. Okay. Okay, so here's a chain rule for any function in the form of e as the base, and that's a power in gx. Okay, so let's see if you have f dash x. Okay, so and you differentiate e to the power gx x. Okay, you see the problem here is this is gx, but the variable in your denominator is x is not exactly the gx, so that's why you apply the rule for the e to the power x right here. So you have to create a train. So what kind of train? Okay, so the train is right here. So that's gx. So you create a gx here. And of course, after you create that, you have to create another one here just to cancel it out. All right, and your x is still here. All right, so at least we understand for the first part, I mean for this part, you could get e to the power gx, okay, and of course dgx over dx is just derivative of gx. Okay, so that means when you differentiate a function in the form of e to the power gx, what you're going to do is just e to the power gx. So you just rewrite the whole function, but then you multiply the derivative of its power, which is g pi x. Okay. All right. So if you need some time to digest this, okay, just pause the video, think about this for a couple of minutes, try to make sense of the whole thing. Okay. If you are all right, so then we are going to do example 5. Okay, so in example 5, it is pretty much e to the 3x. So you will see this 3x is the problem. Okay, so you have to find a way to use the chain rule. Okay, so what I'm going to do is try to differentiate e to the power 3x. Okay, because I see that 3x is the power, so I'm going to create that 3x right here. And I'm going to rewrite that 3x to follow that part. And the first part is just e to the power 3x. And the second part, of course, is a differentiate 3x, it's just 3. So 3 to the power e to the power 3x. Okay, so that's it. All right. Another one, again, the key is how can we deal with when the power is minus 2x. Okay, all right, that's A, that's B. All right, so you d e to the power minus 2x. Okay, and d e to the power minus 2x. Okay, and right now, remember that that function in the power is minus 2x. So you have to create that minus 2x right here. You create that minus 2x right here. And dx. Okay, so the first part is just itself. So, and the second part is minus 2. Okay. So after two examples, you might have seen, okay, the idea is always when you differentiate such thing, you just rewrite the function and multiply the derivative of its power. So that's a shortcut. If you don't want to go through all the chain rule, you just go straight to the result. That's okay. But I would like you to learn more about the chain rule. So that's why I write the whole process. If you don't like it, you see, so I perfectly understand what you mean. So you can go straight from here to here, right? You just, okay, I just write that's e3x, e to the power 3x, and then times the derivative of 3x, which is 3. And you can go straight from here. So you just jump over just skip the chain rule. You just go straight to the final the result, right? You just rewrite that e to the power minus x, and then you differentiate that's minus 2x, which is of course minus 2. Okay, so there are two more questions here. Okay, so this one I will get you to try it out. Okay, I will get you to have a go. Okay, for this one. Okay, so I would like you to spend at least 3 minutes. So you need some time to go back to see what happens in the A and B. Okay, for some of you, I would encourage you to try D as well. Okay, so after you've done C, if you want to try D as well, that's okay. But let's do C first. Okay, I'm going to pause the video, and you try C, and in 3 minutes time, I'm going. Okay. Okay, for C, what I'm going to do is, okay, 2x plus 1, right? dx. Okay, so, and the power is 2x plus 1, so I'm going to create that 2x plus 1 in the denominator. I'm going to multiply the same thing right here. Okay, the first part is just itself. The second part is 2. Okay, so because d1 just equals 0, and you should okay with that. You should be okay. That's it. Okay, and you might need more time for if you haven't done D. Okay, just spend more time on D. All right, so you might need more time, 5 minutes to think about this. Okay, for D, if you have tried, okay, you can. The key is for the first part, you have to use the index law. Okay, so 1 over e to the power x. Why don't we just rewrite that into e to the power minus 2x and e to the power 3x? All right, and okay, so I'm going to differentiate, and there are 2 parts of it, and I'm going to separate them. You must separate them because there are 2 terms. Okay, and for the first part, okay, it really depends on you. If you don't want to write the chain rule, you can just go straight to the answer, right? Okay, so anyway, all right, sorry. Okay, the first part, you just rewrite itself, the function, and the second part is minus 2 plus. Okay, so the e to the power 3x times 3. Okay, and so the function is minus 2e to the power e minus 2x plus 3e to the power 2x. Okay, sorry about this. Okay, so that's it. Okay, so just pause the video, spend some time to copy all the answers. Okay. All right. So for example 6, okay, I'm not going to do this. So right here, because I would like you to go to the OneNote. Go to OneNote. And okay, and do your own answer. Do your own answer. And track them with the PowerPoint in the OneNote. Is that okay? Right, so it's good luck. Okay, and so that's example 6. Okay, for the next video, I'm going to do example 7, and also I'm going to do some gradient problem, and then I'm going to do the Porter rule and the Quotient rule as well, and then I'm going to give you some homework. Okay, that's it. Thanks for watching. We'll see you next time.